Hello students. So today we will discuss about our new chapter, that is triangles. Right, so you have some basic ideas about how many types of triangles are there. So we first of all we differentiate triangles by two criterias, right? First one is on the basis of angles, and second one is on the basis of side. Right, on the basis of angles there are three types of triangles. That is, on the basis of angles there are three types of triangles. One is acute angle triangle, second right angle triangle, and third one is obtuse angle triangle. Acute angle triangle, in acute angle triangle our angle is less than 90 degree and is greater than 0 degree. Right, in right angle triangle our angle of one angle of a triangle is equal to 90 degree, and in obtuse angle triangle our theta or angle of one triangle is between 180 degrees and less than or greater than 90 degree. Right, so your theta will be ranging from 90 degrees to 180 degrees. Right, so these were the three criterions by which you describe a triangle. There is another way in which you can differentiate a triangle, and that is on the basis of sides. Right, so on the basis of sides you have three types of triangles, that is scalene triangle, isosceles triangle, and equilateral triangle. First of all, scalene triangle is that in which all three sides are different. Right, in isosceles triangle two sides of a triangle are equal. It can be any two sides, right, and the third one will be of different length. And talking about our third type of triangle, that is equilateral triangle, so the length of three sides will be equal. In this chapter basically we will be studying in depth about the property of an isosceles triangle. Right, so let us start with congruency. So what do you mean by the term congruency? So you can say that if two given shapes are congruent when the length of the sides of one figure will be equal to the respective sides of other figure. Suppose let us take an example. Here I am taking circle 1 and circle 2. Suppose these circles are of same radius, so I can say that these two circles are congruent. Or let us suppose take a triangle, take two triangles, this and this. Let us name this triangle as A P C, and this one as P Q R. Right, so for the triangles ABC and PQ are to be congruent, the sides AB should be equal to side PQ, AC must be equals to the side PR of other triangle obviously, and side BC should be equal to QR. This is one of the many criteria, or we can say this is one of the five criteria for any triangle to be congruent or any figure to be congruent. Let us see why we are not saying that these two triangles are same. As you can clearly see, the orientation of triangle PQR is not the same as the orientation of triangle ABC. That's why we are not saying that uh, triangle ABC is same as triangle PQR, but we can say congruent, because if we cut this triangle PQR from this paper, and if we try to overlap this triangle PQR on triangle ABC, you will find that this triangle PQR will completely overlap triangle ABC, right? It will completely cover triangle ABC. So that's why for any shape or any figure to be congruent, it must overlap each other. Let us discuss about some other examples. Suppose I have drawn a square, and here I have drawn another square. So for square 1 to be congruent with square 2, these two squares must overlap each other completely, right? So if they overlap each other, I can say that square 1 is congruent to square 2, right? This is the sign of congruency, right? This one is the sign for congruency of two figures. Right, as you can clearly see here in figure 7.3, uh, figure 2 cannot overlap any of the given figures here. Same is with figure 3. Figure 3 can also not overlap any of the given figures. But if you see that figure 1 and figure 4 will overlap each other, right? So we can say that square 1 and square 2 are congruent, right? So in this triangle, let us see which triangles are congruent and which triangles are not congruent. So talking about triangle ABC, you can see that there are whole different types of triangles you can see. So you have to tell which one of them is congruent and which one of them is not. So let us talk about the first and second figure. You can see that the side AB of triangle ABC is equal to side PQ of triangle PQR, and side AC is equal to the side of triangle PQR, right? This AC length is equals to PR of the two triangles, and in the same way BC length is equals to length RQ of other triangle. So by clearly observing the sides of these two triangles, we can say that yeah, these two triangles can overlap each other. Also you can see that the angles are also same, right? Angle BAC or angle A is equals to angle P, angle B is equals to angle Q, and angle C is equals to angle R. So right, we can say here that a triangle ABC is congruent to triangle PQR. One thing that one must keep in mind is that this angle A is equal to angle P, this angle B is equals to angle Q, and this angle C is equals to angle R. So you have to name the triangles in a proper order in which you are proving the congruency. You cannot write triangle ABC is congruent to triangle QPR, right? Because you can clearly see that the corresponding parts are not equal, right? Angle A is not equals to angle Q. That's why we cannot write this thing that triangle ABC is congruent to triangle QRP, right? In the same way, let us see that fifth figure, our triangle SUT. Right, SUT is not congruent with any of the above four triangles. Why? Because in triangle SUT, all three sides are of equal length, but none of the above triangles have length of none of the above triangles have same length, right? So this fifth figure is not congruent with any of the above figures. But on the other hand, you can say one more thing, that is figure first, figure second, figure third, and figure fourth. These four figures are congruent to each other, as the side that we see, right, this side 4.5 centimeter in triangle uh, MNR, this is equal to the side of triangle ABC, right. All of the dimensions present in these triangles are of equal length and equal measurement, so we can say that these triangles are congruent. But the fifth figure is not congruent, right. So there are basically some criterias for a triangle to be congruent, obviously, and those are, for any two triangles to be congruent, we have some set of rules, and those are, first one is SAS congruency rule, second one is ASA congruency rule, third one is AAS congruency rule, and fourth one is our RHS rule, right. We have one more criteria, let me see if I can write it here, that is SSS congruency rule, right. So these are the five. Let us discuss this in detail. Before that, uh, one thing that I want to keep you in your mind is, suppose if two figures are congruent, right. Let us take an example first. Let us take these two figures, triangle ABC and triangle PQR. We are saying that these two figures are congruent, right, by, suppose, these, the length of the sides of these two triangles are equal, right. So their corresponding parts, that means here, if sides are equal, then the corresponding parts, that is this angle A will be equals to angle P, this angle B will be equals to angle Q, this angle C will be equals to angle R, if and if only if the triangles are congruent, right. If the two triangles are congruent, then only you can say that their corresponding parts will also be same, and this rule is known as CPCT, that is corresponding parts of congruent triangles, right. You can see here, know that in congruent triangles corresponding parts are equal, and we write in short CPCT for corresponding parts of congruent triangles. So in the next video we will discuss about those five congruency criterias which are must for any two triangles to be congruent.